All right, so we start out with some true or falsers. Number one, the letters CPCTC are an abbreviation for the phrase corresponding parts of congruent triangles are congruent.
True.
True. That is absolutely correct. Number two, the sum of the measures of the three angles of an obtuse triangle, because it has an obtuse angle, of course, is greater than the sum of the measures of the three angles of an acute triangle.
False.
False. What are the angles in a triangle? Always CA 180, no matter whether it's obtuse, acute, equilateral, right, scaling, blah, blah, blah. All right, number three. If the base angles of an isosceles triangle each measure 37 degrees, then the vertex angle must be 106. True or false? True. How do you know? Because 37 plus 37 plus 107 makes 180, and that's what we're looking for. Good.
106.
What?
106.
Here, tricked you. Making sure you're paying attention. And you are. All right. Number four. If a triangle has two angles of equal measure, then the third angle is obtuse.
False.
That is false. Good. You can have an acute isosceles triangle, or you can have an obtuse isosceles triangle. All right, number five. If two sides, this sounds tricky. There's a little picture here. It's not? It says, if two sides and a non-included angle of one triangle, so here's my two sides, what angle could I choose as a non-included angle? What else? Right, okay, by included they mean not the angle in between the two angles, so it could either be angle A or angle B. So if we know those things are congruent to two sides and a non-included thing in the other one, then the two triangles are congruent. True or false?
False.
False.
What?
Okay, this is not one of our congruency shortcuts because the angle is not in between the two sides, so this would be side-side angle, which we learned does not necessarily always work. Right. Okay, number six. It is possible to construct a triangle with side lengths 12, 15, and 25 centimeters. Yes, that's correct. What has to be true about the two short sides of a triangle relative to the long side? Right, it has to be greater than the longer side. Okay, good. All right, number seven. Always helps to draw a drawing if you are confused. Number seven. So here is triangle ABC. It says the measure of angle A is 52 degrees. The measure of angle B is 88 degrees. And that means the measure of angle C has to be 40. Then it says side AB is the shortest side. True. How come? Because it's across from the smallest angle. Okay? Smallest side across from smallest angle, biggest side across from biggest angle. Okay, number eight, the altitude to the base of an isosceles triangle bisects the vertex angle. Crickets. The altitude of an isosceles triangle. What is the altitude of an isosceles triangle? What does the altitude mean?
Straight down.
Straight down is always to the middle. Like would an altitude be to the middle of this triangle? No. So right. So the key part is that it's going to be perpendicular. So if I go from there straight down perpendicular, does that cut that angle in half?
Yeah.
Yes. Because it's an isosceles triangle, you know that this side is congruent to that side. This angle is congruent to that angle. That angle is congruent to that angle. So these two triangles are congruent, which means these two little angles that we made are congruent as well. So the answer is yes. Number nine, if the measure of an exterior angle of a triangle is 45 degrees, so let's make a little triangle. And let's make an exterior angle in that triangle measure 45 degrees. Okay? If the measure of an exterior angle of a triangle is 45 degrees, then each of the corresponding remote interiors also has a measure of 45 degrees. So first let's talk a little bit about vocabulary. What are the two remote interior angles relative to angle C? A and B, right. They're the farthest ones away from angle C. Does angle A and angle B have to equal 45? No. What do we know the relationship between these two remote interior angles and this angle right here is? There is something that we know to be true. What will this angle right here be for sure, angle C?
C will be 135.
135. Okay, you know that for sure because these two guys have to add up to 180, right? Okay, so I don't know what these two individual angles are, but if this one is 135, they're going to add up to what? 45. I know that A plus B has to equal 45, okay? It could be 20 and 25, it could be 5 and 40, but if this is 135, that's how that's going to go. So, what's that?
I don't understand what's asking me.
Well, I'm beyond that. That one was false. I'm explaining something that we do know about this angle and these ones right here, and that is that these remote interior angles will always add up to that guy right there, okay? So number 9 is false, right? It's not that they each measure 45, they add up to 45. All right, number 10, side angle is a congruence shortcut. How many people think true? How many people think false? Survey says it's true. Number 10 is true. All right, so let's take a look at these ones. These were a little bit tricky for you on your quiz. Okay, first of all, are these two triangles congruent?
Yes.
Yes? How can you tell? Okay, good. They are congruent because I have a side, an angle, and a side, and I have a side, an angle, and a side that match up. So those are congruent by side, angle, side. And I don't like the way this test sets those questions up. That should be the first thing that they ask you is, are they congruent, yes or no, and then how? Okay. Now tell me what triangle is congruent to MXD. How would I have to write the other one?
MYT.
MYT, good, because M is the same as M. Y and X go together, are corresponding angles, and T corresponds to D. Okay? All right, let's play again. But let's change things a little bit. All right, so first question is, can you tell that those two triangles are congruent, and if so, how? Yes, by what? Angle, side, angle, because you have an angle and a side and an angle, and an angle and a side and an angle. All right, so those two are congruent by angle, side, angle. So what triangle is triangle TAM congruent to? TOC. All right. All right, let's play it one more time. This time we know this, this, and that.
Flowchart proof. Uh-oh.
Flowchart proof, get pumped. All right, number 3. First of all, can you tell those two triangles are congruent?
Yes.
No.
No.
This it would be a situation where the angle that we know is not in between the two sides that we know. So if I write them in order, then that means that I would write SSA,
That's what I put.
which we know is not a triangle congruency, and so what you write is cannot be determined. Okay? And this is a little bit confusing. Some of you are putting cannot be determined and then you're writing an answer. Okay? So you're writing cannot be determined and then triangle BNG is congruent to BXY. Okay? You can't do that. You can't say I don't know the answer for sure and then tell me what the answer is. If you say cannot be determined, then you do not give a triangle congruence. That's all you write is cannot be determined. And I would caution you against being lazy and writing CBD, because there was one on the quiz where the triangle sides actually were CBD. So I couldn't tell if you were saying cannot be determined or if you were naming a triangle congruency. So go ahead and take the extra 15 seconds of your life and write it out.
15 seconds or special. Something else.
Pretty sad, but it takes 15 seconds for that.
Okay, this is a tricky one. We've got two congruent sides, we've got two parallel sides. If those two sides are parallel, what angles do we know are the same? Yeah, we do, because we have two parallel lines. What? So we know that this one right here is congruent to that one right there. It has to be the angles that are touching the parallel sides. So we do not know that this angle right here is congruent to that angle right there. Okay? Because for all we know, this side could be tweaked out way that direction, and then those two definitely would not be the same. Okay? So it has to be the one that's touching the parallel lines. Whoa, too far. Okay, what else do we know?
The middle one is
The middle segment is congruent to itself. So do we have a triangle congruency here?
Yeah.
Is the angle that we know in between the two sides that we know? No. Therefore, we do not know what's going on. So this is another cannot be determined. And this is a weird one because those triangles are congruent, and there's another way that we'll learn later to prove that. But we don't have the tools right now, so we're just going cannot be determined and we're done. What? You say hi, Mom?
I said hi, I'm Alex.
Oh, hi, I'm Alex.
Yeah, you're
I'm Alex and I know it. You're going to be famous.
I know. Always. Astrology was like 5.
Looking forward to Thanksgiving.
Pumpkin pie?
No, little wild blackberry
Ooh,
pie.
I like blackberry pie.
Grandma's bringing it. All right.
9.
Triangle HOW is congruent to triangle what? All right, so we need to figure out first, can we show that they are?
How?
What is the piece of missing information? What?
Angle side.
Right, angle, side angle, because I know that since these two angles are vertical angles, they are congruent to each other. So that gives me angle, side, angle. Remember, anytime you have two angles in a side, you're good. But if you have two sides at an angle, the angle has to be in between the two sides. All right, so triangle HOW goes with triangle what? T, because T and H go together. Y, because Y and O go together. And then W. T, Y, W. All right, and then the last one of these crazy things. You're right.
I am?
You are. His name is Alex, and he's really smart.
Is a 6 meter?
What?
6 meter.
No.
Yeah, the angles are in the wrong spot. So you might be inclined to look at this and say, well, just like in the last problem, I've got an angle and a side. I also know that this angle is congruent to itself. That's what we just did. And he just told me anytime I have two angles and a side, then they're congruent. So what's the deal here? Well, what's the difference between where this side is located in the triangle on the left and where this side is located in the triangle on the right? Yeah, they're switched. This side is in between the two angles. This side is not. Okay? So they have to be corresponding parts that are congruent. It's that whole CP-CTC thing for this to work. And so this is cannot be determined. Okay? How are we doing with time? We're doing perfect. Lots of time. All right, and then everybody loves these.
No, I know.
That's not true. You're just saying that.
No.
How could you not love these fun problems? Oh, that's another lie. Now I know you're lying for sure. Good at all this.
I love these problems. I'm so good at them. What?
Now it's not
I know what A is.
Okay, what's 8? Alex, what's 8?
36.
A is 36. How do you know?
Because 144, the other one.
All right, they told us I didn't mark it on here. Sorry, these two lines are parallel. And so that means if this is 144, then A has to be 36, so that those things can be supplementary. Okay?
I don't believe it.
What's B?
36.
Also 36, because these two guys right here have to add up to 180 as well. So that was 36.
C was kind of hard.
C 72.
C is 72, good, because if this is 36, then that means that this is 36. So these two angles have to add up to what? 144, and since it's an isosceles triangle, they're both equal, so they have to each be 72.
D now.
So is D.
Okay, right. D, you can basically use the same reasoning, but it's going sideways. If this is 36, these two angles have to add up to 144. They're also both equal, so that means that D is also 72. And I'll just label that one in case we need it. Do we have an E? Yep, we have an E. Okay.
No, it's actually 70.
108.
This one's 36, which means this one is 36 because those are vertical angles. Since this is an isosceles triangle, if this is 36, then this is also 36. Those two add up to 72, which means that there is 108 left over for E. All right?
Yes, you had that wrong.
What about F? What?
16.
Not 16, it should be 16. Because 164 plus 16 makes 180. No, you said 16, which is wrong. So F is 16.
What the heck?
What does G equal?
74.
74, because 74 and 16 have to add up to 90 for this to be 180 degrees. And then finally that leaves 70 for h because 36 and 74 makes 110.
I didn't get
180 minus 110 is 70. And I think that's it, right?
That's right.
Yeah.
You say that the angle is 144 and vertical or does that not work here?
You could, yeah. Because if you consider this together all one angle. Yep. So once you know that that's 74, you can go 144 minus 74 and get 70. Yep. Yep.
Okay, isn't the 30th a half day?
No, the 7th is a half day.
This month's been going by fast.
Yeah, November's a great month for students and teachers. All right, so we are going to tackle flowchart proof here, and they haven't given us anything, boys, except for the structure of the proof. And so we're going to start with 3 statements and 3 reasons. And it doesn't really matter what order you put them all in. What's one statement that you can write for sure? Okay, good. You can always start by saying angle D is congruent to angle C because that is given. They told us, so that's this thing right there. So while we're on that topic, what? Okay, same thing. You can say segment DE is congruent to segment EC, and that is also given. So that's this piece right here. So we've used that up. So what is a missing piece of information that you can get from the diagram that was not given to us to start with?
Angle 1 and angle 2.
Okay, angle 1 is congruent to angle 2. How do you know that? They're vertical angles. All right, so from those...
Wouldn't E be?
I'm sorry?
What about E?
What about E? Okay, good talk. From those 3 pieces of information, what triangle can we determine is congruent to what triangle? Okay, so we're going to go triangle DEA, and you can do that any way you want. But once you choose DEA, you have to do the same order over here. That's going to be CEB. And how do we know that? Angle, side, angle. Because we have this side right here that's in between the... Well, you need to turn... I don't know, you're spending so much... Yeah, okay, good luck on the test. Angle, side, angle. So that's good. And then the last step is always the thing that you are trying to show, which in this case is AE is congruent to BE, and we now know that to be true by the world famous CPCTC.
That's always the last one.
So yeah, it's not always, but it usually is. So on the test tomorrow, make sure that you really give this a try, because this will be a 10-point question. There's 10 answers in there, each one worth 1 point. So don't just skip that one. I mean, at the very least, you should be able to get 4 points by writing this, given, that, given. Okay? And you should be able to get another point by finishing with CPCTC. Maybe throw in another one by naming the triangles. And then if you can't fill in the other stuff, at least you got more than
8%.
Okay. All right, and then the last one. Now you have to come up with a proof to call your very own. So on this one, like I said, we're on our own. And so I'm just going to show you how to do this using the old 2-column proof way, which is basically the same as a flow chart. What's the first thing that you can write? PR is congruent to PQ. And over here I'm going to write my reason, and that is given. And then I'll label that on the drawing. PR is congruent to PQ. All right, what else?
PT is congruent to Q.
PT is congruent to PS is also given. And that's this little piece right here and that little piece right there.
Now,
Okay?
what about the two angles?
What do I know about angle P? It is congruent to itself, so I can say angle P is congruent to angle P, and that's because it is the same
So it's
angle.
isosceles.
What?
So the triangle does that.
Nope, I'm talking about the triangle at the very top, not these two triangles down there.
I'll start myself out.
Yeah, I'm aware of that, that's why I said nope. Okay, and so now I can say triangle, usually once you get three pieces, that's going to be enough for you to do a congruency thing. So this triangle right here, the upper left, how would you like to name that? PTR, so triangle PTR is congruent to, so if we went PTR over here, we're going to need to go PSQ over there. And I know those two things are congruent because I have two sides at an angle, and luckily for me, the angle is in between the two sides, so that is side angle side. So that allows me to show or say that QS is congruent to RT, and that is by what? See. Okay. All right. So there's all the fun stuff for you. Okay. All right. So I'm going to say that the back page now today and the back page on the test tomorrow will be extra credit. So I'm going to give you the last 17 minutes of class to work on that back page on your own or with a partner. There are two construction problems in there. We're not going to mess with those. Okay. So get what you can done on that, and then when I collect your test